All right, good evening and welcome to another machining live stream. Hopefully you guys can hear me all right. This is I guess it's the third live stream. I went back and watched the first one and the whole first half of it where I'm doing all the programming that all got cut off. So we did get to see, I think, all the machining though, so that was nice. But this one, hopefully things go smoothly. We can do it all in one nice stream with as few glitches and hiccups as possible. So I guess without further ado, what we're going to do tonight is turn this block of aluminum into the Titan-2M. Again, this is from the Titans of CNC Academy, Titans Building Block series. And this is the second part. And this whole series, it's just an educational program that Titans of CNC generously puts out to help people like me who are trying to learn how to get into the industry of machining. And they go step by step through the process. And if you have a machine, you can follow along. And so for maybe those of you that don't have a machine but are still interested, this live stream will let you see step by step how that process goes. And then one day when you do have your machines, you'll, if you need any help or guidance, you can see where I ran into issues and not make the same mistakes that I may end up making. So without further ado, let's get into programming. So we're going to go to the Titan building blocks. We're going to do the Titan-2M. All right, so first we're going to need to sketch it up in Fusion 360. So let's go ahead and get this started. This, make it a little bigger.
Hey everybody, welcome to Titans of CNC Academy. My name is Billy Boyce, and right now I'm going to take you through modeling the Titan-2M. Okay, let's go ahead and get started. First thing we want to do is make sure we are in the design workspace. And we're going to go ahead and just come up here in the top left-hand corner.
Last time,
and
nothing.
Click Create Sketch.
Here.
Now it's going to ask us what plane do we want to create this sketch. Let's choose the top plane. And then we're going to come up to the top left again.
Nice having easy square parts that we can put in a vise.
Now I'm just going to click one time right in the center and drag down to the right. I'm going to type in 1.95. Press tab.
For some reason it highlights
I'm going to press enter.
The other box first for me.
And there we go. So now we're going to come up here to solid. Say extrude. It's going to go ahead and automatically select
solid extrude
the closed rectangle that we had there. And I'm just going to go ahead and type in minus 0.75 and then press enter.
Right.
And there we go. So now we're going to go ahead and put a chamfer on these corners. So we'll come up to modify chamfer. I can select
saying that we're doing a chamfer, not a.
So I'm going to do that. We have the chamfer type.
I don't know how we're going to chamfer that. That's going to be interesting. Oh, okay, it's a big chamfer. Never mind.
Enter, and there we go.
I was thinking like an edge break.
Add the corner fillets. We'll go to modify
like this.
Fillet. We have one here, here, there, here, here. These last two. And those are a 0.125.
That's huge.
Enter, and there we go. Now we can go ahead
and
move on.
Is that what he said, really? Is that what he put in there?
2 of 3. Here we're going to.
I guess it would help if I actually looked at the drawing instead of just following exactly what they do. But
enter, and there we go. Now we can go ahead and move on to the next print, sheet 2 of 3. Here we're going to add the 6 holes in the top. So I just went ahead and hit top. It rotated the view, so I was looking.
I got one of the space mice.
Kind of rotate it left and right.
So I can do all sorts of weird stuff.
Okay,
I'm not
so
the greatest at it yet.
Create sketch. I'm going to choose that top plane. I'm going to create some points. I'm going to go ahead and kind of look at the print and just kind of mimic the pattern a little bit. Now I'm going to press D for dimension. I'm going to go from our origin to this first point here. That's a distance of 2.125. Again, from the origin to here, 2.875, enter. From here to here, 2 inches. From there to here, 3. Now we'll go this direction, 0.35. Oops. 0.35, enter. From here to there, 0.975, enter. Here to here, 1.6, enter. And now we'll go ahead and use constraints to line everything else. We'll go horizontal, vertical. Make sure this one and this one are in line. This one and this one. This one and this one. We'll make sure this one is in line with this one.
Boom.
And that one with that one. Now we should be able to go finish sketch. We're going to go up here to hole and go ahead and select your points. You might get a preview of a really big hole cutting your part in half. Don't worry about it. Just go ahead and try to select all 6 of those points, and then we'll fix that over here in the menu. Want to make sure we have 6 selected. We're going to go ahead and set that to distance. Hole type, it's going to be simple. We're going to tap it, so go ahead and select that one. We'll do full thread and an angled drill point. The call out for the depth is 375. Let's just go ahead and take that drill 1/2 inch. Want to set the drill tip to 140 degrees. Thread type is going to be a ANSI unified screw thread. And we want to make sure we go to quarter, 0.25. The designation default is 1/4 and that's what we want, so we'll stay there. And we'll go ahead and leave the rest alone. We'll say okay.
Nice.
And there we go. Let's go ahead and move on to sheet 3 of 3. Here we're going to do a couple cutouts and some fillets and do the chamfer deburr. So let's go ahead and come up to create sketch. We'll choose that top surface and we'll do a 2-point rectangle. Now I'm just going to let it snap to the edge. I'm going to click one time and then drag over to the bottom edge and then click again. Again, just let snap and snap. Now I'm going to press D for dimension. I'm going to go from our origin to the first line, 0.5, from here to here, 1.5, from there to here,
Nailed it.
3.5, from here to here, 4.5. And we can see on the print that is a depth of 0.4. So we'll go up to solid, extrude, choose those 2 rectangles, type in -0.4. Enter. And now we have those cutouts. So let's go ahead and come up to fillet. We'll go ahead and choose our 8 edges that we just created by that cutout. And those are 20,000, so 0.02 and enter.
Chamfer.
So the only thing left now is to deburr these sharp edges on the top. So we'll go modify, chamfer, say there, 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 and the bottom. 0.01.
What bottom did he
Enter.
choose there?
And there you go.
The actual
that is
bottom?
the Titan. So we'll go modify, chamfer, say there, 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 and the bottom. 0.01.
Boom.
Enter.
So that's the
And
modeling.
there
So
you
that
go.
one was
That
simple.
is the Titan-2M.
What? Deep. Okay. make a project called live streams. Okay, so that was sketching it up. Now we get to actually do the programming. So that should be for the Tormach video.
Hi everyone,
Hi, Nicole.
I'm Nicole with Titans of CNC Academy, and in this video I'm going to show you how to program the Titan-2M for the Tormach. To begin,
So I'm going to take actual measurements for this one.
We're going to come up to setup, and we want to change our orientation to select Z-axis plane and X-axis. We're going to use this top face for our Z-axis and this back edge for our X. Next, we need to change our origin to model box point, and with model point highlighted blue, we're going to select this back left edge. The next thing we need to do is go to our stock tab, and we need to make sure our mode is
okay,
set to
so
relative
I selected it. Why did it not move the axes? The axis face, X axis. Model box point, right there. What did I possibly miss?
Tab, back left, back axis. And we want to change our orientation to select Z-axis plane and X-axis. We're going to use this top face for our Z-axis and this back edge for our X. Next, we need to change our origin to model box point, and with model point highlighted blue, we're going to select this back left edge. The next thing we need to do is go to our stock tab, and we need to make sure our mode is set to relative size box, and we're going to change our stock.
I don't know why the axis hasn't moved. I click a different. If I click there, it works. What's up with that? Okay, I guess I just have to click like a dozen times, and then maybe it'll work. Okay.
Stock offset mode to add stock to all sides.
Okay, this is where I'm going to measure.
0.05
I cut this a long time ago on the bandsaw at, oh shoot. The bandsaw at the Megatory.
Stock offset mode.
So it's probably a little more square.
I'm going to add 0.05 to our
All right,
X.
so we have 5.1, 5.15. I need to get like a regular pen around here. Like, what did I say that was? 5.153. That sounds right. 5. And I think what they're using is 5.153 minus 5.1. No, we want minus 5 because we're taking all the stock off the model. So obviously it's going to be 0.153. Divide that by 2, we'll put 0.0765. So that's for our X. For Y, go this way. 2.0035. That's close enough to 2. But we'll just do what she does, which is probably going to be.
And 0.025 to our Y. I'm going to do 0.23 for our negative Z offset and 0.02 for our positive Z offset. So your dimensions should show 5.1 by 2 by 1. And we'll go ahead and click OK. The next thing we need to do is face our part. So to do that, we're going to come up to 2D
I'm gonna call
and down
this
to face.
Titan-2M. 2D up to face. It's gonna be
We're
our
going to select
base
our tool
mill.
from the building blocks library, and we're going to use that 1.5-inch face mill that we created in the Titan 1M video.
Oh, come on, it's gotta be here somewhere. There it is.
Change my RPM to 4,000 and our cutting feed rate to 20. I'm just going to change all of these to 20, and we're going to move on to our geometry tab. I don't really need to select anything in here, so let's just go straight to heights. In here we need to change everything to model top. And now we can move to our passes tab. In here I'm going to change my pass direction to 180 degrees, my pass extension 0.76, and my step over is going to be 1.4. The direction I'm going to set to climb, and then I'm going to move on to our linking tab. In here I'm not really going to change too much. I am going to turn off our lead in and our lead out and click OK. Since we set our direction to 180 degrees, it's going to be starting on the left side, and it's going to be starting off the part because of that pass extension we set. So it's going to come straight down, make a cut, and then it's going to come up and over. Since we set our direction to climb, it's going to start on that same side, and it'll be a nice, clean, consistent cut.
Oops. I'm not gonna make you watch this twice. Their camera angles might be a little better though.
Our tool we're going to do is out our part. So to do that, the next thing we need to do is rough out our part. So to do that, I'm going to come up to 3D and we're going to go down to adaptive clearing.
Using a
In
half
here,
inch.
I want to select our tool from the library. We're actually going to be using a 1/2 inch flat end mill this time. And we'll click OK. I'm going to do 4,000 RPM and I'm going to do a 25 inch per minute feed rate. We'll do our lead in and lead out 25. I'm going to do 15 for our ramp and our plunge. I don't really need to select anything in geometry, so I'm just going to leave this and move on to our heights tab. In here, I want to change everything to model top. And our bottom height offset is going to be -0.77. In our passes tab, I want to change our optimal load to 0.025.
Alright, so -0.77 moves that all the way to the bottom of the part after we take off. So it's 7,500.75 inches tall. We're taking 20 thou off the top. That's why we're going an extra 0.77. This should leave, what, 0.23 inches on the bottom. Some of that's going to be in the parallel. So hopefully we can avoid kissing the jaws, the hard jaws of the vise with our end mill again.
And I'm going to change our maximum roughing step down to 0.8. I'm going to select the box that says flat area detection, and I'm going to change our stock to leave to 5 thou. Next, we'll move over to our linking tab. In here, I want to Next, we'll move over to our linking tab. In here, I want to change our retraction policy to minimum retraction. We're going to change our stay down level to 70%. And
so it looks like I have slightly different. She gets a maximum stay down and then a minimum stay down. I get a safe distance. Just gonna bump it up 0.2. Lift height 0. Yeah, it looks like they've changed. Oh, is it because I hit pocket and not adaptive? Restart. Let's try 3D. Edit.
Plunge, depression.
Sorry about
Our
this.
everything time we're gonna go is rough out our part. So to do that, I'm gonna come up to 3D.
Yep,
and we're
that
gonna
is
go down
different.
to adaptive clearing. In here, I want to select our tool from the library. We're actually going to be using a 1/2 inch flat end mill this time.
1000,
And we'll click OK. I'm going to do 4,000 RPM, and I'm going to do a 25 inch per minute feed rate. We'll do our lead in and lead out 25. I'm going to do 15 for our ramp and our plunge. I don't really need to select anything in geometry, so I'm just going to leave this and move on to our heights tab. In here, I want to change everything to model top. And our bottom height offset is going to be -0.77. In our passes tab, I want to change our optimal load to 0.025. And I'm going to change our maximum roughing step down to 0.8. I'm going to select the box that says flat area detection. And I'm going to change our stock to leave to 5 thou. Next, we'll move over to our linking tab. In here, I want to change our retraction policy to minimum retraction. We're going to change our stay down level to 70%. And I'm going to change our ramp type to plunge. And we'll set an entry position in this corner along this edge here. And click OK. It's going to walk around the outside of our part, cutting out that outer profile. Then it's going to work on these pockets here. And you can see it's going to stay down on the surface since we set such a high
totally different than what.
It's just going to keep looping back.
Okay. I hate to go back and watch that part of the video a third time, but yeah, there's something different about that. 25, 25. It's probably like a step over or something.
Back around here, and we'll set an entry. We're gonna our next we'll change. I'm gonna load it.
Okay, let's
And
find
our
out what
bottom
we
height
did
offset
differently
is gonna
there.
be -0.77. In our passes tab, I want to change our
That's
optimal load
why.
to
0.025.
0.025.
That's a big difference.
And I'm going to change our maximum roughing step down to 0.8. I'm going to select the box that says flat area detection. And I'm going to change our stock to leave to 5 thou. Next, we'll move over to our linking
That's
tab.
What is that? 300,000 inches per minute non-engagement feed.
Retraction.
Let's make that 25 so we don't break something.
To 70%. And I'm going to change our ramp type to plunge. And we'll set an entry position in this corner along this edge here. And click OK. It's going to walk around the outside of our
my
part,
cutting feed rate.
cutting out that outer profile.
Oh.
Then it's going to
holy
work on these
smokes
pockets here. And you can see it's going to
How did that sneak by? I literally put 300,000 inches per minute as my cutting feed rate, and it was okay with that. Like, really? What machine does 300,000 inches per minute? All right, just for fun, 300,000 inches per minute. 300,000 inches. So there's what? 12 inches in a foot. There's 5,280 feet in a mile. So I just programmed this machine to move at 4.73 miles per minute. So I guess we have to divide that by, or multiply it by 60. Do some dimensional analysis here. I programmed it to move at 284 miles per hour. And the machine would have tried to do that, I think, if we didn't catch that little glitch there. So that's why you got to be careful. The machine, it will try to do what you tell it to. The machines usually don't make mistakes. I've heard of it happening, but yeah, it's usually the what do they say? The nut behind the steering wheel that causes most of the problems. So this should be a much finer toolpath. Yeah, that's what we're looking for. Okay. Simulate that really quickly.
Since we set such a high stay down level, it's just going to keep looping back.
You can watch this simulate while we skip the actual machining video. So again, you're going to watch this on the machine. If you stick around. You don't have to stick around. Do what you want.
So the next thing we need to do is finish the outer profile of our part. So to do that, we're going to come up to 2D and down to 2D contour. Now we're going to be using that same 1/2 inch flat end mill, but I am going to change our feed rate to 20 inches per minute. I'm just going to change them all to 20. In geometry, I do want to select this outer profile on the bottom here. And in our heights tab,
really have to make this like a preset.
Top again. Our bottom height offset is going to be -0.77. And then we can move on to our passes tab. In here, I want to change our compensation type to where. And we can actually add in
2D contour, passes tab, passes. Okay. I jumped the gun a little bit.
a finishing
Alright, so
overlap.
4/10 is tolerance left. They say to do where, but I haven't messed with that enough to get it to work on the Tormach. Every time I've tried it, it throws an error, so we're going to leave it in computer. So I won't have a compensation radius. Oh, she didn't. What else did she change?
Next in our
Did she change anything else?
type to where. And we can actually add in a
Yes, she
finishing
did.
overlap of 10 thou. Next in our linking tab, the only thing I really want to change here is just going to be the lead-in sweep angle.
I wish they explained why they're making changes like that, or like
And we'll
why we're adding an entry
entry
position.
Same one as last time in this edge here. Next we'll click OK. So you can see the tool is going to drop down below the bottom surface of our part. And it's just going to walk around the outside of our part, cleaning up the outer profile.
Always do that.
Is finish our pockets. So to do that, I'm going to go ahead and duplicate this contour. I'm just going to right click it, click duplicate, and then I'm going to right click the new one and hit edit. I'm going to use the same feeds and speeds and the same end mill, so I'll leave that alone. I'm going to move on to our geometry tab, and I'm going to close the current contour selection. So I want to select the right edge of each of our pockets here. You'll notice when I select one of them, it wraps around this radius here, but it doesn't select this one. So to select it, I'm just going to click that line again, and it should highlight light blue. Now we can edit the contour. I'm going to select this radius that I want to add, and then hit the little plus button that says accept current contour. And then I'm just going to do the same thing on the other side.
You hit and scroll. Oh, you click it. It helps to pay attention. So you click it until it's light, and then you click it again and accept current contour.
Perfect. Now with those selected, I can move on to our heights tab.
I don't think I would have noticed that it
already
didn't wrap around that.
I do want to change our bottom height offset here. We're just going to change it to selection, and I'm going to select this face, and I want to change our offset to 0. Next, in the passes tab, there's not really much I need to change. I don't want a finish overlap here, and I actually want to add in roughing
Why do I
passes.
keep skipping passes?
We do want our step over to be 0.25, and now we can move on to our linking tab.
All right, she said step over as
Not
point.
really anything.
Probably missing something. If
And
you
now we
saw
can
it,
move on
say
to
it
our
in the
linking
comments.
tab. There's not really anything in here I'm going to change. I do want to get rid of our entry position though. After I close that, I'm going to click OK. So you can see our tool is going to come down. It's going to clean up the center of this pocket. And then it's going to make a second pass, cleaning up these radiuses and this wall here. And then it's going to come over and do the same thing on this pocket as well.
A slightly different result. So
and then it's going to make a still is going to finish overlap. Perfect. Now with those selected, I can move on to our heights tab. Everything's already set to model top. I do want to change our bottom height offset here. We're just going to change it to selection, and I'm going to select this face, and I want to change our offset to 0. Next, in the passes tab, there's not really much I need to change. I don't want a finish overlap here, and I actually want to add in roughing passes. We do want our step over to be
see, told you I missed something.
And now we can move on to our linking tab. There's not really anything.
Fortunately,
it
was obvious when I got a very different toolpath than she did.
Though. After I close that, I'm going to click OK. So you can see our tool is going to come down. It's going to clean up the center of this pocket. And then it's going to make a second pass, cleaning up these radiuses and this wall here. And then it's going to come over and do the same thing on this pocket as well. Side of our pocket. So the next thing we need to do is the other side of our pocket. So it's going to be the exact same thing, only on the other side. So we're just going to duplicate this. I'm going to right click, click duplicate, right click edit, and we're going to change our geometry. I want to remove the current contour, and we're going to have the same problem on this side. So I want to go ahead and select the line, select it again, add our radius, and click accept.
All right, I think I want to go ahead and program the second op before we start machining so we can go right to it. And I need to remember to install that stop.
Everything looks good in here already. I don't really need to change anything. We'll move on to our passes tab. In here, I need to uncheck roughing passes. We don't need to do that extra pass.
Okay, so I guess she actually did do something different there. She unchecked the roughing passes.
Anything in here, go ahead and click OK. So just like the last operation, it's going to be coming down and finishing these pockets and these sidewalls here.
Wonder how they mount that camera. Might be like on a tiny little tripod.
So the next thing we need to do is chamfer the top edges of our part. So to do that, we're going to come up to 2D and down to 2D chamfer. Now we're going to select our tool in our library.
So we haven't used this one yet.
3/8 chamfer. Go ahead and select OK. We are going to run it at 4,000 RPM with a cutting feed rate of 20 inches per minute. I'm just going to go ahead and change all of these to 20. And in our geometry tab, I want to select the top edges of our part. You just have to make sure, since the chamfer is modeled in, that we select the very top edge and not this bottom contour here. So if we were to select the
I'm
bottom,
gonna
it would
definitely mess it up.
There we go. Now in our heights tab, we just want to change everything to model top. Now we can move on to our passes tab, and I want to change our
Keeping it in
compensation
computer
type to where. And we're going to actually change our chamfer width to 0 since the chamfer is modeled in.
Interesting.
If it wasn't modeled in, I would add the width, but since it is, it's just going to be 0. The tip offset,
50,000.
we're going to do 0.05, and I'll go ahead and just leave the chamfer clearance in there. That's good. Move on to our linking tab. In here, I want to change our horizontal lead-in to 0.075. Our angle, I'm going to do 45, and then I'm going to change our vertical
And I
lead-in
wish
radius
they
to
explained
0.
why they were doing that.
And we'll click OK. So you can see our lead in there, and you can see our tip offset in there so that it's not right on the tip of the tool. That'll help extend tool
Too
life.
fast to see what it's doing. That's too slow. Boom. Yeah, you can see that tip offset.
For the bottom edges of our pocket. So to do that, I'm just going to duplicate.
Control
this
D
last toolpath.
duplicates.
Right click duplicate, right click edit. And we're going to use that same tool, same feeds and speeds, so that's all good. In geometry, I do want to remove our current contour selection. And I'm just going to select the 4 edges of our pockets here. In our heights tab, I am going to change our bottom height from selection, and I just want to select the bottom face of our pocket. And now we can move on to our passes tab. In here, I do want to add a chamfer width since it's not modeled in. I'm just going to do 5 thou. Our chamfer tip offset, I'm going to do 0.125, and our chamfer clearance, I'm just going to do 0.02. And in our linking tab, there's not really anything I need to change. I'm just going to leave that alone and click OK.
All right, so now we just basically, it looks like we just have to drill the holes,
right there.
chamfer the holes,
In there.
tap the holes.
It's going to come across. Just
I'm
put
going
nice
to grab a
little
bottle
edge
of
break
water
on
while
this
this
pocket.
is...
The next thing we need to do is spot drill all of our holes. So to do that, we're going to come up to drilling, select drill, and we're going to use that 3/8 chamfer. So I'm going to leave it in there. It's going to be 4,000 RPM with a 20 inch per minute cutting feed rate. And we're going to move on to our geometry tab. We want to make sure our hole mode is set to selected faces, and with our hole faces highlighted blue.
I'm going to save this because I just almost closed out of it, I feel like. Trying to close the tool library. I would really hate to have to restart this. So we're going to use our chamfer mill still, 4020. Right, let's back up just to be sure.
Highlight, leave it in there. And we're going to use that 3/8 chamfer, so I'm going to leave it in there. It's going to be 4,000 RPM with a 20 inch per minute cutting feed rate. And we're going to move on to our geometry tab. We want to make sure our hole mode is set to selected faces, and with our hole faces highlighted blue, I'm just going to select one of these holes here. Next, I want to make sure the box that says select same diameter is checked. And now we can move to our heights tab. All of these need to be changed to model top. And our bottom height offset is going to be -0.1375. And we're going to change our cycle type.
Okay, yeah, we're just doing
drilling with a full retract. And I'm just going to do our peck depth of 0.04. And click OK. So you can see where the tool is going to drop down here. And it's going to lift and spot drill each of these holes.
blood coolant. I bet we're gonna end up duplicating that. And we're gonna use our .2283 drill or whatever it is. Yup. And then I'll wait for her. I don't need to watch it do every hole. That's excessive.
Duplicate that.
You'll watch that on the
path.
machine.
So right click, duplicate, and right click, edit. Now I need to change our tool. We want a drill. So in the library, we're going to use the .2283 drill and click OK. 4,000 with a 16" per minute. That's perfect. Our geometry is already selected, so I don't need to do anything there. In our heights tab, the only thing I really need to do is change our bottom height offset to -0.65. In our cycle tab, I'm going to change our cycle type to chip breaking with a partial retract. I want to do our pecking depth of 0.075, our minimum pecking depth 0.05, our accumulated pecking depth is going to be 1 inch, and we'll do a chip bake distance of 0.01 and click OK. We made sure that we've got plenty of room for our tap. That looks really good.
Cool. All right, we're getting there.
So we're going to go ahead and duplicate that last toolpath again.
Duplicate.
And
Could do
right-click,
Control
edit.
D, but instead I'm searching for it.
Now we're going to change our tool. We're going to use the 1/4-20 tap and click OK. We're going to change our RPM to 550. Our holes are already selected, so I don't need to do anything in the geometry tab. In our heights tab, I do need to change our bottom height offset to -0.5. And in our cycle tab, I'm going to change our cycle type to right tapping. And we'll click OK.
Do I want
got our height-
a dwell period? Maybe. I'm not going to mess with it. Right hand tapping cycle selected, but the tool is not a right hand tap. Do not want to ignore that warning. I did not change the tool to my 1/4-20 tap. Thanks for the warning, Fusion. 1/4-20. Be that one. Okay. I'm gonna go ahead and like this video for them. I think it helps YouTube creators when people watching the videos like them.
That way we make sure we get a nice solid
I've heard.
thread all the way down to where our call out is on the print.
Ah, look at me. I hit 0 instead of the next arrow. That's not what we wanted.
Hi.
Okay, so
I hope you enjoyed this video. Thank you
I
for
think
watching.
that's done. There's a few things I want to try here. So, Tormach Smart Cool. There's something in here where it's making it do like an air blast here. I kind of like that.
And the final option we have for using the Smart Cool is an air blast mode or a Q value. This works really nice with the flood coolant option. You can just add an auxiliary air blast to clear some chips or to clean the part off. So for this, we'll shut the wiggle off, which is just a standard M9. I'm going to turn on the flood coolant, so I'm going to close the doors here. So I'm going to just do a M8 with a P0. This is going to point the coolant at the tip of the tool, and then I'm going to say a Q of
M08 P0 Q2. Okay, so I'm going to try to post this. And, ooh, maximum coolant air blast in seconds. 2. Smart Cool equipped, yes. Go to that live streams. Boom. Okay, so we're gonna post this. think that's where I wanted it. Titans of CNC probably. Usually do this on the other screen. Live stream. There we go. Titan-2M. We'll make a folder for it. Okay, so when this posts, I'm gonna dig through it. Okay, so we have M8P0. So I'm gonna go M8P0 Q2. Basically, I wonder if I can do that in a smarter way. Can I do a control, find, and replace? There's gotta be a place in files, control shift H. Okay, so I'm gonna search for M8P0 and replace it with M8P0 Q2. This might be dumb. I don't think it's gonna break much. All right, so what do I hit? Place all. Boom. Could have been really dumb. We're gonna find out. All right, so I'm also gonna save this to my flash drive. All right, Tormach. I'm gonna call it Titan-2M. And I don't think they actually have a video for the second op. So we're gonna have to do that one the same way we did Titan-1M. So it's just decking off the top and chamfering it. So let's pull up the drawing just so we don't get this quite wrong. Okay, so the whole thing is 0.75 tall. We start with an inch. So I'm going to make a new setup. Is that what he did? You know what? Let's just be sure. This was a really quick video. Thank you for your patience. Alright, so he saves it as another file, so we'll do that.
Left, I'm just going to keep it up.
Titan-2M, op2.
Upper left, okay? There's no holes or features.
I think I'm going to delete this.
So it's nice and clean, all right? So I'm going to come up here. I'm going to hit this guy.
Go back
Z
a tiny bit.
and X. I'm going to set up. Boom. All right. Now we're doing the opposite side. Because we're upper left, I'm just going to keep it upper left. Okay. There's no holes or features on the second side, so it's nice and clean. All right. So I'm going to come up here. I'm going to hit this guy. Z and X. I'm going to hit Z. I'm going to hit X. Boom.
Z is the face, right? And
around.
X is the back. Yeah, looks good. Model
And then I'm going
box
to come over
point.
here. I'm actually going to say model box
Boom.
point. Click this guy.
You gotta say
click
boom.
this
And that's
second
probably his
time.
catchphrase. Hopefully he hasn't
Boom.
trademarked
That's
it.
where I want to be. So now let's actually put our stock where it needs to be. So I'm going to come over here. Stock on all sides.
See, this is why
Boom.
I write things down. 5.153. So, and I probably shouldn't have closed my calculator, but I got off subject with my feed rate of like 400 miles per hour. Actually,
So this is
76 and a
50,000
half.
rounds. I'm going to go 50, 50, 50, 50. Now, I'm actually going to come down here. Watch this, 0.23. So that's how much stock we have, right? And you can see the material that drops all the way down. And I really don't care about that, but just to be clean, and because this is for education, I'm just going to make it exactly how it's supposed to be, okay? So we're going to put it right here. I'm going to say negative 0.75. See? So it knows right where the model's at. Negative 0.75 just took it right to the other side. All right, so I kind of tricked it a little bit. So that's how much material we have on our model. Okay, we're going to cut this off. So I just say okay, boom.
Again, this was for the
make it happen. So we're going to come up here. I'm going to actually go to 2D face mill.
I'm going to have to
go to building blocks. I'm going to grab
down a little bit
face mill, just like before.
Right,
all right, but now we're not just facing the top. We actually have to make a couple roughing passes. All right, so I'm going to show you how to do that. So let's just change our RPMs. Let's go to 4,000. Boom. Come down. So 4,000. Cutting feed rate is, let's say 25. Tab through 25, 25, 25, 100. Boom. Looks good. Geometry, it knows exactly where it's at. I'm going to say that's okay. We go to our heights. Now it's going to be a little bit different because I have more material over here. Okay, so model top is fine, but let's raise it up to 1 inch. Retract 1 inch. Let's go feed. That's where it starts feeding. Let's put that at 0.5, which is about a little over a 1/4 inch above where the stock is. And this we're going to put right at 0.23. All right, so that's telling it where the top of the stock is. Okay, so now I'm going to come over here to bottom and it's at 0 and we are good. So I'm going to hit passes. I'm going to go 180, pass extension 1.7. I'm going to drop down.
That's probably actually fine.
Here is the difference. Now we're doing multiple depths. So I'm going to hit this guy. We have 230 thousandths. So 0.23. Let's do 3 passes. Okay. So let's do 0.080 per pass. This shell mill will nail that easily. All right.
We're going to keep it at 40.
Do a finish step. Boom. 25 inches a minute. But here we're going to say 5 thousandths. So now you're going to go 80 thousandths and it's just going to step down. Boom, boom, boom. And then do one more pass at 5 thousandths. All right. No stock to leave. I'm going to come over here. I'm going to drop down. I'm going to get rid of these guys because I don't care about them. I'm going to hit this.
That's a lot of passes.
Boom. And look at that. So it actually drops down, comes across, drops down, comes across, drops down.
40 thou versus 80 thou.
Right?
I mean, I think it took the 80 thou last time, didn't it?
All we have to do
was just
is chamfer
eating it.
The top of the part, which is actually
Let's see what this Tormach can do.
Not to confuse you.
Let's in our passes, I think it was. We'll go maximum step down of 80 thou. Boom.
You guys, but let's go over here. Boom. Drop down. Go grab
Let me
our
just
tool.
do a chamfer. We're using the 3/8 inch.
We'll go to building blocks. Now we'll go get our 1/4 inch chamfer. I'll okay it right here. Boom. We'll just drop down 20 inches a minute. That's fine with me. It's just education. So keep it nice and safe. Boom. Boom. 100. Boom. All right. So everything looks good right there. Geometry. Go right here. There's on the other side we had
did model that contouring on this one, so we did have the double lines.
So when you come in and look at it, it's just
so again that means
surface,
we're not gonna model in a chamfer width.
Click on the inside line or outside line because there's only one line. So I'm gonna come over here, 0.4, 0.2, 0.1.
Can bump that up a
0,
bit.
0. That's all fine. I'm gonna leave that alone. I'm gonna come over here. I'm going to actually say chamfer width is going to be 10 thousandths. And I'm going to come over here, offset my tool at 50 thousandths. That'll be good. There's nothing to clear, so that's fine. I'm going to come over here. On this guy, I'm going to say 0.1, drop in, and I do not need this guy right here. And I'm just going to hit OK. Boom. Looks good. So you can see it. It's dropping in. Dropping in, going around.
I was
boom,
thinking.
Coming around, coming out.
Staring blindly off into space. Trying to think of how that stop's going to come into play. We'll think about that. We'll talk it out once we're in the machine. Okay. I think that's about it for this, right? Ah, shoot.
Boom. Looks good.
I'll just simulate this toolpath real quick.
Dropping in, going around, boom, coming around, coming out. That all looks good. So that's it. Look at that. That's just 2 tools. So let's come up here. Let's go to where our tools are.
Okay. So
and
let's post that.
One is 15. Let's just renumber
Call
them.
it Titan-2M op
Now
2.
it's 1 and 2. All right, so let's get out of here. Now you see it's 1 and 2. I'm going to simulate it.
Pictures live stream.
Drop down. Simulation. Let's watch it.
CNC live stream.
Comes across. This is really important. Like, you want to make sure that it is absolutely perfect.
Right, so there's our post. G-code.
I can see the shell mill is not going anywhere except exactly where it's supposed to go. And it's a beautiful thing. And there you have it. Everything looks absolutely perfect. We are done with the second side.
Okay.
So now we're just going to come up here and post it. Boom. We got B right there. I'm going to hit this guy.
Okay, so we have now got op 1 and 2 programmed on our USB. So we should be done with YouTube. We do need to set our tool offsets, and I also need to get I don't have my GoPro set up yet, so let's get that going. Can you hear me all right? Yeah, looks like you can hear me. So cool, that's turning on like I want it to. Let's see, how do you do this anymore? It doesn't like doing what it's supposed to do. So I think when I did this, I unplug, come on, be nice, HDMI, and plug it back in. Is that the trick? Still working out some of these hookups. I should have done this earlier, but the longer this camera's turned on, the hotter it gets, and then it shuts off, and then it's just a nightmare for everybody. All right. Come on. Aha. There. Boom. All right. Look good? Let's go to the machine. So we got our parallels in there. Safety glasses time. Please always remind me if I'm not putting on safety glasses at the machine. Okay, so we got to set our tools. Shoot. We got like random tool numbers, I think. I'm going to go back and we're going to print up a setup sheet. How's that sound? So I'm going to open this setup sheet. Sure. Darn it. I thought that would work. Okay, let's print that. So I don't like that. 2D contour. Because we actually still have those other tools in the machine. I don't know if you could hear me there. We actually do have those other tools in the machine, so let's do this the right way. Let's look at our tool library. So tool library. What? This is missing stuff. Ugh. Let's go look at that. Okay, so something went terribly wrong. It looks like what? I deleted setup 1 and then all right, we're going to do this the hard way. So, because I don't want to recreate everything that we just did, our G code should be good. That's a big should. But we got tool 17, that's our face mill. Doing adaptive with tool 2. That's long. 3D toolpaths are a ton of code. A ton of code. Holy smokes. What do we got here? Oh, more G code. There's probably a way to like... No. Thinking maybe it was like Excel and you could use a hotkey to jump to the end. Okay, 2D chamfer, drill. Okay, so our G code. Yeah, so the good news is it's other than this 3-inch face mill. I wonder if I could renumber this like 18. Start from 18. And we'll read. Okay, good. It didn't like retroactively do everything. We'll renumber this one as 1. I think this is what I want. So now we have, basically it's the Titans library 1 through 16. But we're using a 1.5-inch shell mill instead of a 3-inch shell mill. Okay, so T9 is our drill, 0.2283. Where's tool? This is... So, I guess that's the same tool as the chamfer. So the chamfer is tool 14. Yep. Tool 14 is our 3/8 chamfer. Contour, that's still with our tool, I think it was tool 2. So we got to remember, I think it in the G code, it's T17 is our 1.5 inch shell mill. Okay, and then T2 is our 0.5 inch, half inch flat end mill. Alrighty then. Okay, so we have to set off some tools, offset some tools. One thing I want to check real quick, see if there's a handy YouTube video. Hey, look, I'm live on YouTube. Tormach Timer height offset. Well, hey, this is exactly what I wanted.
Hi, Jason with Tormach. Let's talk about how to use your Heimer to set up your work offsets.
So I actually have one of them.
The first step to using your Heimer successfully is to making sure that it's properly calibrated. We did an entire video on this. If you haven't done this already, please check out that video. So the Heimer's kind of a unique edge finder. It allows you to set X, Y, and Z axis all with the same tool. So it's really a time saver when you're setting up your machine. So you can see on our dial face here, when we move the stylus over, we get the 2 indicator needles move with it. When we line both the small red needle up and the large black needle on 0, it compensates for the diameter of the ball. So it also makes it quicker since we don't have to remember what size, and it just kind of reduces some error opportunities. But it also works in Z. So to use this with Z, we need to set the tool length like we do all of our other tools. In our system, the way we like to teach tool offsets is the distance from the spindle nose to the tip of the tool. This tool is a little unique. When you're comparing it to like a solid end mill, there's no compliance in an end mill. With the Heimer, there is some compliance, so we need to preload the Heimer to the 0 location.
Okay, so they're using what I'm using.
So to measure the tool offset, you really just want to do the same process you're going to do to set all of your tools. So
here's what I'm going to do.
Gauge, measure your Heimer at the height gauge. If you're going to use a piece of paper or touch the parts off and your tools off in your machine, then
I'm guessing you just put it in there and press it down manually until it reads 0.
So we're going to go ahead and show you how to do it on the granite block here.
0 it.
So what we do is we just the height gauge down right on the top. We 0 this out. And what this is representing in the machine's mind is the spindle nose. So we 0 this out on the spindle nose. We raise it up and we preload it. As we put tension on this, the easy way to do it's the height gauge has a little lock on it, so we can lock this top portion and we can use the thumb screw to dial it down to 0. So then we just watch our face here as we dial down, and we just keep going until we make it to 0. So as you can see, we have 4.7655. One thing to note is if this is under tension, it is a spring tension, so if you don't put a little bit of pressure here, it can lift up the indicator, the height gauge base. So it's just kind of good practice just to kind of keep a little pressure here while you're checking your number.
So then they're just going to plug that as an offset.
4.7655. So once we have our number, then we can just enter that into the offset table in PathPilot. So we jump to our offsets tab. We go down to the tool number we want to enter it at. We're going to use tool 50. We're going to enter a description in here. So just put Heimer. And I'm going to enter my length offset at my 4.7655. And we just hit enter. The standard stylus on the Heimers is right about 1 inch long. They do make an optional long reach stylus.
Let's just send it. Let's see what happens. All right, so I'm going to be lazy and sit down for a minute, or continue sitting down for several minutes. So let's go, and then I say that, and then I stand up. Offsets, tool 50, Heimer. He's got it set at 4.7606, so I'm curious to see if that's what we end up with. So you can kind of see me. zero that out. So not seeing how this dial is working. Well, I guess it's lifting it there. The opposite should drive it down, right? Sure. Nice. So 0, 0, 4.766. 4.7. Well, we'll put what we got, 4.766. And just to be sure, I'm going to zero that again. And it reads 0. Okay. So just because if you have it, you might as well use it. I'm going to use this USB height offsetter thing that Tormach makes. For whatever reason, I bought this without even owning a Tormach machine back when I was using the Makatory. 0. Why is this flashing so much? Is the battery dead or something? Stop it. I highly doubt I have an extra battery. Oh, it just popped right out. You know what? I would have one of those, but not here. It'd be at home. It's just one of those standard, like, flat CR2032, I think it was. But anyways, taking the battery out made it stop flashing, so that's fantastic. Make it back to inches, zero it out. I should probably plug that in. Boom. Okay, so let's just do this one more time. We'll zero this. Zero. Come up. Put it on the Heimer. This is riveting entertainment for your Friday night. There we go. Too far. Gently. Okay. 4.769 it says. So let's hit data. Boom. 4.768.9. Okay. I guess it's a little more accurate than what the readout is. Okay. So that's our tool 50, and that is allegedly set. Maybe I'll do it later. Tool 1 needs to become tool 17. So tool 1 is 1/2 inch shell mill. I'm just going to copy that height of 0.26625. And that's going to, what did I say it was? 17. So 1/2 inch shell mill. How about 1.5 inch? That would make a lot more sense. .5. Copy in our 2.6625. Short little stubby tool. Okay, so tool 2 now. I'm just going to move these guys out of the way because they were not in the correct order. They were in the order for what we were doing last time. I renumbered them all 1 through whatever. So tool 2 is actually a 1/2 inch flat end mill. 0.5. All right, so here's our length. We'll get that set up here. 3.175. Boom. That's tool 2. And it's actually tool 2. Okay, now tool 14 is our 3/8 inch chamfer. So tool 14. 3/8 inch chamfer. And our diameter, I'm just going to put in, it helps when you hit enter on these things. 3/8 inch chamfer mill. Okay, now I got to select the length. And this one's very pointy, so you got to hit it just on the tip. 8118, and this was tool 14. Previous owner of this machine was so nice to label everything for me. Tool, is it 9 or 19? It's got to be 9. Well, how do we get tool 14 as a 3/8 inch chamfer? Well, it is. But tool 9 is our drill. So let's get this. This is tool 9. We'll call it our 0.2283 drill. Come on. DRILL. Enter. 0.2283. Enter. Get it lined up. Data. Boom. And the drill was tool 9. Okay, and now the fun part, our tap. This is our 1/4 tap. Make sure it's installed correctly. This is the big honkin' tool. And it's tool 12. 1/4 tap. Not TSP, tap. What, 0.25? That's our diameter. The height is a whopping what happened? It did not like that. I'm just going to hand jam it in there. 7.399. And then, oh, it came unplugged. That's why it doesn't like it. So, 0, 0. Come up. Okay. Data. Okay, it took it that time. And this was tool 12. I don't like putting in this shelf, but because it's kind of top heavy, but we'll do it for now. It'd be a shame to break the tap from that. Okay, so tool, we are just about ready to go. Grab my USB stick. Remind me to install that work stop. I think this goes here. Come on. That is a tough screw. Let's put it in a position where we can get to it. Mallet time. Wow, that was tough. All right, so yeah, we should be able to make that work. Okay, so let's get rid of any tips that might be hiding. Wipe it with our finger. Our parallel keeper is in there. The parakeep. Alright, that's nice and tight. It is sitting on the parallels. Parallels can move a little bit. I'm going to try that one more time. Snug it up here. Make sure it's on the parallels. Give it a whack and tighten it down. I'll just say that's good enough. Okay, now the work stop. Just going to put this right on the bottom so it's out of the way. Actually, let's do that again. Now that the work stop is installed. I said it would be one more time, I lied. Alright, so let's get it actually pressed against the work stop there. Snug it. Whack it. Okay. Let's hope that's good and out of the way. Let's get this out of the way as well. All right, so our tools are offset now. We need to locate our part. And for the first time, I'm going to try to use the Heimer for this. So the Heimer is like a three-way indicator, basically. I'm very careful with it. Set our step to a single thou. We're going to get this right up close to that top corner as we can. Bring it down just a scooch. Now we're going to come in until it reads 0. It's moving. Getting real close. All right, that's like right on the money. So I'm just going to say that that is our 0 and X. Move it off of that, move it up. Move it down. I'm actually going to make our step to 10 thou. Boom. This is our Y. It's 7 thou off of the last time, which means our indicator might be up to 7 thou off. Interesting. Maybe we should calibrate that, but not tonight. Okay, now let's come off of that. Come up, back. And now we'll get Z. Too far. Okay. So that's our Z. And to check it, first I'm going to go to G30. I'm going to pull the Heimer out. Boots are like too big for this switch, I'm telling you. Or maybe it's just too far away to be. Okay, so let's get our pointy tool, which is tool 14. Let's load tool 14. And I'm going to do a MDI G0, which is a rapid move X Y0, and I'm going to put a semicolon between. So I think I need to do G0, Y0, G0, Z3. So this should stop 3 inches over the part. Okay, so let's go G0. Rapid. G0 Z 1.2 should stop 1.2 inches over the part, and see how confident we are here. G 0.05 50 thou. This will definitely see if our both our Heimer's set up right and our tool offsetter is set right. So I didn't actually save it there. G0 Z 0.05. Rapids at 9%. Yeah, that's pretty close. I don't have like a 50 thou shim, but we'll see. Okay, back to G30. You can go 100%. Okay, this was tool 14. I think we got our USB in there, so we'll go File, USB, Tormach, Titan-2M, copy, Titan-2M, Op2, copy. Okay, so Titan-2M, load the G-code. We haven't had the coolant running this whole time, so that's probably needs to spin up. I haven't warmed up my spindle yet either. But now why did it go there? I typed in 500. I went to like 4,000. Okay, so let's think about what we're doing here. We're taking tool 1, which is our shell mill. Let's do a test. Tool 1, enter, coolant off. We're gonna go G0, X0, Y0, Z 1.5. Okay. G0, Z 0.05, and we'll move our rapids down to 13%. G0, Z 0.05. That's pretty close. Okay, let's hope for the best. Let's send it, as they like to say. So let's stop. Cycle start. Tool length that says a 0, that's a bad sign. We'll go back to rapids at 100%. Insert tool 17. Ooh, stop. So tool 1, tool length is 2.6625. Tool 17, 2.6625. Okay. Let's go to rapids 30%-ish, and we'll hit cycle start. Coolant comes on. Ooh, our air burst is going too, but it's not pivoting like it's supposed to. So that is taking a tiny little cut. Okay, it does pivot down when it does the air burst, so that's nice. I'm going to bring the rapids back up. That looks awfully like it's leaving a lip. No, there's no lip there, surprisingly. Alright, so now we got tool 1 is done. So now we go to tool 2. This one will slow the rapids down on again. Start at like 50. How about 37? Because that's where I ended up. I didn't check our minimum Z here, but looks good. Looks like it missed the tool stop too, so that's good. Can't tell if it's actually making a cut on that side. I don't actually see any chips. Yeah, I think our alignment might be off a bit. So hopefully whatever error we had in our exposition there, it gets made up for by the stock on the sides. Starting to make those grooves now. This will be a long tool path. To 100 rapids, not that it'll speed up the cut in here. So our smart cool doesn't seem like it's moving enough. It's wobbling, but it's not hitting the point where it's supposed to be hitting. So this is where we really could bump this up quite a bit, I imagine. Take a much more aggressive cut. But since this is just for education, they slow it down to 20 inches a minute. It's actually kicking chips out right through the door where I'm watching it. I'm gonna try to close that. There you go. These doors got banged up on the move. Looks like we're getting some water in the compressed air there. That's not great. Need to get that worked out before I get the Haas. where air is actually used to lubricate the spindle bearings. Absolutely thrilling. About maybe about a third of the way done with this tool path. Our adapter clearing here. I wish our coolant would actually hit it. Just about to break through on this side. Maybe this pass. Real thin. Oops, I tapped the cycle or the feed hole. Ooh, a little bit of chatter there. There, it broke through. Give me a big chip. Interesting. It made like a wavy. Oh, it really needs to clean up that back spot. All right, so let's think what that stop's going to do. So that stop is currently touching the edge of the stock. So it's currently touching the edge of the stock, and we flip the part over. It's going to be resting on the model itself. Right? So if we flip it over and touch it against the model, I don't think that's really going to tell us much, you know? I think we'll still have to indicate in X and Y and Z. It's not looking. Kind of bird's nested up in there. Lost in thought. Yeah, I don't think the work stop's going to be like the end of our problems there. If we just put it in there and hit cycle start, I don't think our chamfer will line up at all. Well, actually, oh, no, we added 50th out of there. I'm dumb. Yeah, we messed this part up. We didn't account for the stock when we used the Heimer. The Heimer accounts for its own position. We might be able to save it yet. So that's why we're doing this. You don't really know until you do it and make the mistake, and then you hopefully remember. So I think because we had excess material in X, it's actually gonna work out. Unless the backside's all jacked up. Which is a possibility. Because that backside's off by 50 thou. And this left side's off by like 96 thou. So maybe in the future, if you were setting up jobs, if you're using a probe, do you want to go off the models? Use the model as your origin? I mean, that removes variability in the size of your stock, but if you're probing it, so much to learn. That's the beauty of it. I really hope it cleans up that little flap sticking back there. I mean, when it does its finishing passes, it should. I should have stopped right at the beginning when I knew that the back wasn't getting cut. But I think we'll still be able to salvage this. Or at least get something that's close. And know what mistakes were made. Because after I do this all in aluminum, I plan to go back and do them with a steel. There, it broke through. Interesting tool path. So we're going to clean that up right now. Look at that. Got it. So this should be our finishing passes. I guess this is adding the fillets. I mean, it is making slight cuts on that side, so it's doing something. Finishing pass. For some reason I thought there was another one, but... Alright. What is next? Chamfering. Yeah, that's like spraying water on there. That's not fantastic. All right, tool 14 is our chamfer tool. We'll lower the rapids on this. That's actually hitting the tool tip there. Just when it turned on, it did. Can't tell if it's actually hitting it. I kind of see light coming off of it. It's reflecting back at me. I only really notice it when the coolant's running down it though. It's interesting. This is going to be the scary moves where it goes low and does the chamfers. That should be spotting the holes. Oh my. It's starting way above the surface. That's not great. But maybe that's how we set the model height. what? Normally I would spray that with the air gun, but if it's spraying water, that's probably not great. Tool 9, our drill. And the final tool, tool 12, the tap. Go rapids to 100%. Oh, that's not great. Is this not the quarter 20 tap? Do we have more than 2 taps? Two, 2, 8, 3. Let's check the drill. Ruh-roh. That was the wrong drill. So all this time I had the right drill, it was just in the wrong box. If that's not the right drill, what's this? That's the box that says 2283. Okay. Back to where we were on the first one. When then we actually did have the right drill, we just didn't know it. Now we don't have the right drill for real. Fortunately, we didn't break the tap on that first attempt. So, shoot, what's going to be closest to 2283? Fractions in your head are hard. How about 2? We're going to get yep, that'll be too big. Well, 0.23. It's still smaller than a quarter. I don't know what the minor diameter of quarter 20 is. Shall we? This is reckless. Well, that's an ER16. Here's an ER20. That looks like a thread mill. That might come in handy. I got all sorts of bunch of goodies from the guy that sold this machine to me. He gave me a bunch of tool holders. Okay. So now I need to find a collet that holds that. This is a 3/16. Where's my collet holder? Okay. Isn't it great when you like don't have a system for anything, and so you just set the specific thing that you need down anywhere and expect to remember where it is? There we go. Okay, what collet? 7/30 seconds is the winner. It's very snug. So we stopped this in the middle of a tapping cycle, which is kind of dangerous. Okay, let's call this T. Stop, reset. I'm gonna pull the, freaking GoPro. Why do you do this to me? Come on, man. All right. Over to the GoPro. Yep, it's a GoPro. Come on, GoPro. You don't need to play videos. Oh, it's playing a video. Man, it would be cool if I knew how to use a GoPro. Boom. Okay. We are back. So offsets, where were we? Our drill was 9, and that's not what it is. You know what? It doesn't matter what the diameter is because we're not doing any. Yes. Z limit switch is active. Z limit switch is active. Okay, so we gotta turn off limit switches. Okay, yeah, I agree. Turn off the limit switches. We're gonna go. It is not E-stopped. So right brings it down, up, left. Okay. So we gotta bring it off the limit switch, turn the limit switch back on, home the Z. Remove our tapping head. Inspect the damage. Okay. So I'm just gonna hand jam this one. Turn it on. Zero it out. I said 0 it. Come on. Why do you know 0? Okay. 4.075 is our offset for the drill. 4.075. Okay. So we're going to call that tool 9. This is really stupid, but we are going to start at line 22387. And we are going to load tool 9. And we're not going to break anything. It's just going to work, right? Right? There's a big chip there. Tool 9 loaded. Turn this off, get it out of the way. And mass carnage ensues. Big chips, holy smokes. It is like birds nesting. Ha! It's beautiful. This will bite you. All right, so that picked up pretty well. Let's see if it's big enough for the tap. Still stops. Drats. Cool, cool, cool. So we need a bigger drill, I think, right? So exciting. I don't know how you like to spend your Friday nights, but this is pretty interesting, I think, since I'm probably doing it. So since I'm the one doing it, I'm a little biased. All right, so let's take that. Got to find a collet for this drill, which is a 15/64 drill. Was a 7/32 collet. Looks like I need a 1/4 inch collet, and all of those might be in use. That's where I saw. It was definitely a collet. Who knows what size it was though. Okay, 1/4 inch. Well, the drill that we used has a 1/4 inch shank, so let's just use this. See, this is how you know I'm not like proofing these out ahead of time. You're getting the raw experience here. Because nobody would like actually make this part correctly and then torment anybody on YouTube with all of these mistakes. So it looks like tool accountability and tool inventory would save some trouble. Cool. Let's get the height, hopefully for the last time tonight. Zero that out. Why does it not actually zero? Why is it saying it's like 3,000s? There we go. Boom. 4.239. Offsets, drill 4.239. Okay. If this doesn't work, I'm like out of options, I think. Cool. So we go back to the end, go to our drill cycle, start at 22387, send it, tool 9's in the spindle. Starting the bird's nest again. Oh, I broke free that time though. So thin chip. So the other option, potential, is that maybe the tap is just slipping in the head, but I don't think that's the case. I want to say the entire head stopped moving. But I'm not good at watching fast things happen and judging what happened. I'd make a terrible like referee or umpire. That's much better. It still does the, I think I need a dwell time, because the machine just like doesn't start and stop that rapidly, you know. Ugh. Gross. I did not like what I'm seeing in those threads. Maybe it's just the first one that's all gummed up. Alrighty. Yeah, I think I destroyed that first hole. You'd think maybe that doesn't look as bad once I blew it out. Okay, so do we dare just go full send right into the op 2? Okay, so here's the part. We can kind of do a post-mortem here and see what happened. So when I used the Heimer, I forgot to add the stock. Another reason why you should always print out the setup sheet and probably use it, because that would have told me. I mean, this is the. It's the one I drew on over here. This would have told me that there was 76,000 stock in the work coordinate system. But I neglected to do that. And so if you pay careful attention, so this was the front, this was the back. You can see possibly that the lip down here is much bigger than the lip on the back. Like it's nearly flush there. The fact that we got the right dimensions on the back at all is like a miracle. And then Again, on the left side, you can again see there's just tiny little overlap there where like just a few thou are taken off, and then all that gap is here. So I almost want to think that the Heimer is off by a few thousandths, and that's why we have a lip here at all. If we actually would have nailed it, it should have been flush. So I definitely think we should have recommended what the video did there, and I think we should have. Interesting. Anyways, yeah, I think we should have. Where was I going? Totally lost my train of thought. Oh yeah, calibrated the Heimer. We should have done that. We shouldn't have just blindly trusted it. Or we could have stuck with a reliable edge finder. You know, I really do think that it did miss a finish pass in here, because you look here, like here and here, it just doesn't have a good surface finish, and there's actually a lip. There's a noticeable lip right there, so yeah, that's not great. And then I take it back. Those threads don't look horrible. Once you get cleaned up. So I would say this is a scrap part. This would not meet the spec for sure. Mostly because of this lip in here. Like, I think we missed a finishing pass, maybe. I think I mentioned that when it was going on. I'm like, should there be another finishing pass there? And you can see we still literally have, like, such a glare. Like, this is, I sanded this off on a grinder at the Makatory back in the day, and that finish is still there. Like, yeah, definitely did not set the work offsets right. So this is a scrap part, so I don't care if we wreck it. I kind of want to just see what happens if we line it up on that work stop. That will answer my question. So if we flip it over like this, we probably actually want side. I don't know. I don't know, but let's try it. Come on, GoPro. You gotta keep up, man. Why do you time out? You don't even feel that hot. Yep, we know. GoPro. Camera. Okay. So, for education purposes, we are going to put this back. I'm going to slide it against that work stop. Flush it up. Look at me not sitting it on the parallels again. And now it's not against the stop. It's like I can only do one thing at a time. Where's my mallet? Okay. So we're going to take our pointy chamfer tool, tool 14, load up tool 14, and go G0X0Y0Z2. I'll be damned. That looks about right. Let's go to G30. And just for my edgeification, we're going to flip it around and see what happens. So this is against the stop. G0X0Y0Z1. That looks about right too. Well, let's give it a whirl, huh? We'll go to our tool change. Tool 14, tool 1. Okay, so now we have to load Titan-2M op 2. Let's hit cycle start. Load tool 17. It's loaded. Oh, my door flew out. Oh well. So this is going to be a big cut, remember. If it knew where it was, holy smokes. We did not set a Z offset. And that's probably... Let's just see what happens. This is education. Well, I can tell you right now, it's not going to cut it that way. So let's cancel this. Go to G30. Let's see if I can fix my door. There we go. So interesting that flipping it this way didn't work. Okay, so what to do about Z? Here's what I want to do about Z. I'm going to take tool 50, which is our Heimer. And I'm going to get my calipers. We're going to go from the top of the part to the parallel. 0.9905. 0.990. So we got 0.990 there. Let's be real, I'm not going to remember that if I don't write it down, even though it's fairly easy. 990. See, I can't even remember where I put. Oh, a pencil? Nice. Okay, 0.990Z. So Heimer is tool 50. right, so we got that zeroed. So I'm going to say that that is positive 990. Is that right? Let's look at our setup sheet for Op2. Op2 wasn't corrupted by me being a dummy and deleting it. So okay, so the lowest it goes, Z min, minimum Z is minus 0.8. Okay, that sounds right. No, it's not. Let's think. All right, so the way we actually set this up was we used the model top, but the model top is on the bottom of the part. So right now we're not actually 0.990. That's just measuring our stock. That's all that's telling. I think what we want, so much to learn, so many mistakes to make. I think we want to measure this little guy. 0.236. 0.236. So at this point we are actually at 0.236. Let's call it that simple. But is that true? No, it's not true, because if we set the tool to 0, then it would only cut, there's more to it. There's more to it than that. What's our minimum depth of tool 17? Our minimum Z is 0. That's good news. So I think that is right. Let's take the Heimer out and go full send on it, since it's a scrap part. Stop, reset, cycle start, tool 17. Please don't crash. That's going to be aggressive. And it is taking it like a champ. Big old chips flying. We didn't do our little air burst processing on this, but I think we'll be fine. This will be another fairly aggressive cut. So this is supposed to be 80 thou per cut. That's kind of impressive for that 1.5 inch shell mill on a Tormach. And it's just making a great surface finish. So we should get one more rough pass and then a finish pass. A little bit of leaking of coolant. I need to seal this up a little bit better. It's running down the window and leaking in. Yep, so that clears off the rest of that flange. And we got our finish passes coming up. Got a significant cold drip leak thing happening here. Okay, so this isn't really going to tell us much about how our X and Y were, even though it is, it's hitting it all. But it's that chamfer tool that's really going to tell us if that theory of just setting it up on the stop is going to work. I like that finish. It's like you can see a reflection in it. Okay, 3/8 inch chamfer tool. Moment of truth to see how our X and Y is. I'm gonna slow the rapids down to about 35. Yeah, it's not doing anything. I always say that, and then when coolant starts flowing down it, it's doing something. There it's taking a deep cut, so we know we messed something up. Okay, and that's up too. Okay, Well, how did we do? Chamfering again is always where I seem to struggle. Wrong button there. There we go. So it did barely kiss the front and the interesting. The sides all got pretty deep chamfer. The back got a tiny bit, and then this edge didn't get like anything. That's still kind of a sharp edge. Okay, so let's think that through. This side was the work stop side. We didn't change our X or Y. I mean, that could just be error in the Heimer. I don't think we'll know until we calibrate it, unfortunately. But I mean, this resembles the part. It looks like the Titan-2M. But you know, if we were to actually start measuring things, probably would find some discrepancies. For example, okay, so go to programming so we can see it. So the thing is supposed to be 5 inches long. That's going to be close. 5.0025. So we're 2.5 thousandths off. It's supposed to be even say, yeah, 1.95. 1.95110, so thousandths off that way. And then 0.75 tall. Wow, 0.7500. So perhaps we nailed, or I just got lucky with the measurement. Nope, 0.7500 there too. So why is our Z so good? We measured that flange to take off. That probably helped. And we measured that against the Heimer. So whether the Heimer is true, like absolute position, that's probably where the error is. Like maybe when it's set up in Z, it might be 7th thou off. Seems like a lot, but it could be. But relatively, you know, once we had it zeroed in, and we said that this is our 0 position, with the height that we told it was. So as long as that 0 held, we should have had a really accurate Z height, and that's looking like it's holding up. 0.751 there. 7515. Cool. Let's see. So this middle section should be 2 inches long. 2.006. I don't even know what accounts for that. Maybe our tool actually isn't the diameter that we said it was. It's not exactly ½ inch. I don't know. Things to try to figure out. And again, like I said before, the surface finish in here is not great. So lessons learned from tonight. Calibrate your Heimer before you use it. Let's see. When you're using a Heimer, don't forget to set up the stock because you're measuring the stock, so you have to account for the stock. So I should have taken the, I think it was like, what, 76 thousandths off. Yeah. 76 thousandths off the x's, minus x and positive x. Didn't do that. I think that's the big ones I can think of. Yeah. So I'm gonna call it quits there. I'll probably try to make this part again. I might not live stream it. I might just make it. And then pass on the lessons learned. Cool. Well, anyways, it doesn't look like there's anybody still watching that, and I don't blame them. We're, what, 2 hours and 45 minutes deep into this on a Friday night. Most people that are that interested in machining probably already have machines and don't want to be watching videos for 3 hours on a Friday night. So anyways, I'm doing this for fun, for my enjoyment. I like it. Maybe one person someday could learn from my mistakes and save themselves some trouble. So with that, yeah, I hope everybody's doing well. And we'll catch you next time. Thanks.